So moving on to applications, I have already discussed you the application part. In that, reactions in which the nitrogen is lost and the reactions in which nitrogen is gained. So moving on to the reaction of the reactions in which nitrogen is lost, in that three applications I have already discussed with phenols and all. So here in the fourth application, it is like alcohols, amines and amides we are taking, which are having the less acidic hydrogen atom. So in this, what happens here is you are treating the Lewis acid catalyst, as well as the in presence of Lewis acid catalyst you are doing this reaction. So Lewis acid catalyst, you know that, for example, it is like BF3, HBF4, etc. So ROH, you are taking an alcohol, and then if you will treat it with the Lewis acid, that is your BF3, and this lone pair of electron will go and attack to BF3, forming you this structure, and then oxygen will gain the positive charge because it is having the 3 bonds attached in it. Okay, so once you will get this one, now the diazomethane comes into picture, and that will go and attack. So diazomethane is having the carbon ion, right? So that carbon ion will go and abstract the proton of your or alcoholic alcoholic H, that is your or weak acidic proton, less acidic in nature. Okay, that it will go and abstract, it will methylate it. Okay, once it will go and abstract, what happens, this bond will neutralize the positive charge of the oxygen atom. Meanwhile, this BF3 will cleave out. Once this will cleave out, that time you will result in an alkoxide ion and diazonium salt. Diazonium salt, again, what happens here is alkoxide ion will go, the alkoxide ion is having the RO minus, that O minus will go and attack to the methyl group by the cleavage of your nitrogen group, that is your nitrogen is lost over here by the formation of ROCH3. Okay, then next application is, in the next thing, it is like amines. If you will take the amines, there is the formation of lactam. So lactam ring. So here what happens, again you are treating it with diazomethane, and if you will treat it with diazomethane, and this nitrogen and hydrogen bond which is present over here, the bond will shift. Once this bond will shift over here, this bond and will shift and make a charge O minus. Okay, once it will have the O minus as the charge, that what happens here is the diazonium salt which will be present over here. Okay, first, once it will have the O minus, at that time it will abstract the proton, and after abstracting the proton, it will do the reaction with the diazomethane, that is your CH2 N2. Once this CH2N2 again will come into picture, and it has to form the diazonium salt, and then you will result in the O methylated product with the elimination of your nitrogen molecule. So moving on to fifth point, that is your conversion of aldehydes into methyl ketones. Here what happens here is, the speciality of this reaction is there is the insertion of the CH2 group into the aldehyde CH. Okay, aldehyde CH bond, between this there is an insertion of the CH2 group. So here what happens, if you will take an aldehyde and then if you will treat it with the diazomethane, there is a nucleophilic addition reaction which is taking place here. This minus atom of the carbon ion will go and attack to the carbonyl carbon of an aldehyde. Once it will go and attack, at that time this bond will shift, make a charge O minus, as this O minus again comes back, make a double bond, and there is the 1,2 hydride shift. Okay, that is first this hydride in the 1 and 2, between 1 and 2 position, it is just going and shifting over here, and then meanwhile there is a cleavage of your nitrogen atom, so resulting you in the methyl ketone as your product. Okay, then moving on to sixth point, it is the either an aldehydes or ketones you have to tell. Aldehydes and ketones also forms an epoxide epoxides as your product with the diazomethane. So if you are taking an ketone and then if you are treating it with diazomethane, again it is having a negative charge. Carbon ion will go and attack to the carbonyl carbon of your ketone. On once it will go and attack to the carbonyl carbon, which is electrophilic in nature. This carbon and oxygen bond which is present over here, this bond will shift, make a charge, and after that this minus charge of the carbon and oxygen, this oxygen atom which is having a minus charge will shift, make a bond. Meanwhile there is a cleavage of your nitrogen molecule by the formation of your epoxide. In the cyclic ketones, like in that application itself, you have to take the 5 to 6 membered form of you will get the 5 and 6 membered form products. It will form 2 of the products if you will take the cyclic ketones. So here you are taking the cyclohexanone. If you will take the cyclohexanone and then if you will treat it with the CH2N2, that is your diazomethane, you will get 2 products. One is your epoxide formation that will have the 17% yield, and one more is your cyclic hexanone. Okay, cyclic 7 1 2 3 4 5 6 7 7 membered ring cyclic ketone formation that will have the 63% yield. So how you will get the lower ring to the higher ring ketones is, how you will get this molecule if you will treat it with this. How it happens is, here is the mechanism. So here what happens, CH2N2, you know that it is having the negative charge that will go and attack to the carbonyl carbon of your or cyclic ketone. Once it will go and attack, at that time there is the shifting of the bond making you as the charge, and then again there is the ring expansion reaction. Okay, so what happens here is, it is not it should not show like this. This charge will shift over here making you as a double bond, and meanwhile there is a ring opening over here, ring expansion reaction with the elimination of your nitrogen molecule. In the cyclopropanation of alkenes, and so here you are having in the presence of light as well as in the presence of heat. Either it can be in photochemical or the thermal condition. So diazomethane decomposes to form the carbon as your product photochemically or thermally. So in the presence of light you are forming the carbon, okay, with the elimination of nitrogen. Here again the nitrogen is lost. In the presence of thermally also you are forming the carbon if you will take the diazomethane. In thermally also, in the presence of heat, you are getting the carbon with the elimination of nitrogen molecule. And here if you will see, here you are taking the catalyst as CuCl2 or PdCl2 in the presence of heat. If this is there, at that time the carbon is formed with the elimination of nitrogen molecule. And one more thing is the carbon gives the addition reaction, okay, to form the cyclopropane ring. In that reaction is known as cyclopropanation. So the carbon will just go and attack to the alkene, forming you as the cyclopropane ring. Thank you. If you have any doubts, you can ask in the comment section. Next part will be there. In that I will deal with the nitrogen is gained, how the nitrogen will retain in that particular reactions.